Alright, today we're going to start Chapter 7 with Lesson 1, which is called the Law of Sines. There's also a law of cosines, and depending on how the triangle's set up, we're going to use one or the other. Everything in Lesson 1, Chapter 7.1, is going to be using the law of sines only. When we get to Chapter 7.2, we'll be using both laws of cosines in conjunction with the law of sines in order to solve missing parts of the right triangle. As far as what you start off with, it's based on what information is given to you. So if you're given angle, side angle, or angle, angle, side information. So for example, here's my triangle. And let's say I've got this angle and this angle given to me, and let's say that side. That's angle, side, angle information. So if I'm given, let's say this is triangle ABC, I'm given angle A and angle C and side B. Whenever we identify a triangle with name ABC, the sides opposite A, B, and C are little a, little b, and little c, opposite each side. So if I'm given angle A and angle C and side B, that's angle, side, angle given. If instead I'm given angle A, angle C, and let's say side A, that's angle, angle, side. So either one of those scenarios where they give me two angles, and either the side in between or a side not in between the angles, I'm going to use this technique. Find the measure of the third angle. These two angles plus this make 180, right? So 180 minus the two given angles give me the third angle. And then the law of sines, which is right here, will find everything for me. Any side over the sine of its opposite angle is equal to any other side over the sine of its opposite angle. That's what the law of sines states. So within any triangle, whether it's a right triangle, an acute triangle, an obtuse triangle, whatever, side divided by sine of angle opposite equals side divided by sine of angle opposite equals side divided by sine of angle opposite. So once I know all three angles, once I find this third angle by subtraction from 180, we know A over sine of A. We don't know B but over sine of B. We don't know C but over sine of C. We create a proportion that's solvable. Those are the easy ones. Okay, they're very basic, very straightforward. If my Algebra 1 class had the ability to type sine whatever in the calculator, I could teach this to my Algebra 1 class. I mean, the level of difficulty is not very high. Case 2 is the side-side angle case, and I do want that order when you identify it, please. Don't put it in the reverse order because that would be not pleasant. Anyway, side-side angle means that we have one side and a second side, and then instead of the angle in between the two sides, we have like this angle over here. Side-side angle, or maybe we have the angle over here, side-side angle. Okay. As opposed to the side angle side, we'll deal with that in the law of cosines chapter. Law of cosines is required when we have side angle side given to us. If we get the side-side angle, job 1 is to use the law of sines to immediately find the other angle. So this side is opposite this angle. This side's opposite this angle. So I have the ability to find this angle using the law of sines. Okay? The one thing about this, though, is sometimes there's a possible answer, sometimes there isn't. If there isn't, you're done. If you do this first step and you get sine of x equals 1.37, you're done because you can't do that, right? Go back to our last chapter. If sine of x equals anything bigger than 1, that's not possible, right? Mm-hmm. So I have to do x equals inverse sine of 1.37. There is no solution, empty set, can't do it. All right? That's a possibility. That could happen. So that's what step 2 is about. If there's a possible answer to number 1, also find the obtuse measure of the same angle. All right? The other thing you learned about sine, inverse sine, let's say sine of x equals 0.2. That means x equals the inverse sine of 0.2, right? And if I use the calculator to find that, inverse sine of 0.2, making sure my calculator is set to degrees, I get 11.54 degrees. But that also means x equals 180 minus that. So 168.46 degrees. Anytime there's an answer between 0 and 90 for sine, there's also an answer between 90 and 180 with the same answer because the height of both of those is the same. So if I tried sine of 168.46, you can see it equals very close to 0.2. Okay. So if sine equals 0.2, both of these answers, 11.53 and 168.46, both would be able to be inside of our triangle, right? 180 degrees in a triangle, both of those less than 180 degrees. Mm-hmm. All right, so if there's a possible answer, number one, find the obtuse measure. So you're going to get two sets of answers. Set 1, set 2. A equals this, A equals that. B equals this, B equals that. Then you want to set up two answer sets and you want to find the third angle. All right. Now, there's one other thing that could happen here. And I don't have any example problems that show this happening, but it does happen in the homework. So let me just tell you what happens. Let's say that you need to find angle C, angle A, angle C, and side C. Let's say that's what we get. Let's say, just for the sake of argument, let's say A is equal to 30 degrees. That means the other A is also 150 degrees, right? Mm-hmm. Right. At the point we know A, and this is B, of course, we already know B, right, because we were given B, right? Let's just say B is equal to 40 degrees, just to give it a number. Okay, so A is 30, A is 150, B is 40. We're supposed to find C and C for this, all right? Well, 180 minus 40 minus 30 is equal to 110, right? 180 minus 40 minus 150 is negative 10. That's another possibility that could happen. That A's obtuse answer is so big compared with the B answer that we got already. We've already used up more than 180 degrees. C ends being a negative angle. Just throw out the second set. There's only one solution possible. That can happen. Occasionally will happen. So if there's an answer, find the obtuse measure. Get A equals. When you go to find that other angle, if you get a positive, you're good to go. Find both sets of answers. But if you get positive, negative for the third angle, throw out the negative one. Again, no examples I have to show you today do that, but again, it happens in the homework. I saw it. All right, so be ready for that. Anyway, the best way to do these is just to do them. There's one example like this. There's two like this. One where number one's not possible. The other one where number one is possible. You get two sets of answers. So we should see most of this situation that will happen today. So, solve triangle ABC if A is 42 degrees, B is 63 degrees, and C is 18 centimeters. You don't have to draw it to scale, okay? But draw a picture. Always draw a picture of your triangle when you're doing this. So, anytime they tell you the name of the triangle ABC, A, B, C are the names of the angles, and side A is opposite angle A, side B opposite angle B, side C opposite angle C. So, when they tell me C equals 18 centimeters, that's little c, that's the side measure, it's opposite the C degree, or the C angle we don't know yet. And the A and the B are 42 and 63. Little a is opposite angle A, little b is opposite angle B. The next thing I want to do after I've drawn the picture is I want to establish what information is given to me in what order. All right? What I'm looking at here is angle, side, angle. So when I look at your homework paper, I should expect to see a sketch of the triangle. It doesn't have to be huge, but don't make it microscopic either. I see people all the time, they'll draw this little thing here, and they'll try and fit 42 and 63 in there and 18. And I don't know, and I get like an electron microscope out and I can kind of make out the 18, and it's kind of hard to read. You know, use some space in your paper. You know, if you have to fit, like, let's say 4 of these problems per page, you know, if you put like a cross like that, 1, 2, 3, 4 per page, that's about the amount. You might even fit 6, but if you're trying to start fitting 8 to 10 on a page, you're not drawing the picture big enough, you're not doing enough work. All right, draw it big enough that you can actually fit stuff in there, you can read it. Identify for me what the angle side setup is. And angle side angle takes me to case 1, right? So I'm just going to follow this process, which says, number 1, find the third angle. So what I know is that the 3 angles add up to 180, so C, the angle that's missing, is equal to 180 minus the other 2 angles. So 180 minus 42 minus 63, that equals 75 degrees. Me personally, as I find stuff, I like to actually include it on the picture. So I'd probably put a 75-degree angle there. As you find stuff, also feel free to circle your answers, because again, it's asking us to solve the triangle. Solving means to find all the missing sides. Some of the homework questions just say find this thing. Find A, find B, find angle C. Others will say solve the triangle. They want everything that's missing. So this one says solve. We're trying to find all 3 things. So angle 75, we still need to find A and B. So once I found this angle, I know all 3 angles on one side. I set up a proportion, and I apply the law of sines. Now, when I make a triple proportion, keep in mind, we go back to Algebra 1 where we did proportions, right, to solve similar triangles. Okay, it has that same kind of structure to it, right? We always wanted the numerical one in the middle where the letters were on either side, right, when we did this? So looking, 18 and 75 go together, they're both numerically known. So if I put 18 over sine of 75 here, then I just need to put A and B on the other two pieces, so the side measures are all on top. A unknown, 18 known, and B unknown. 18 went over sine of 75, A is going to go over sine of 42, and B is going to go over sine of 63. Please be very careful that you put sine of 42, sine of 75, and sine of 63. Don't just put 42, 75, 63. Okay, law of sines requires that signs are there. And each of those has a value. So sine of 42 equals something, sine of 75 equals something, and sine of 63 equals something. I'm going to put those numbers in 4 decimal places in my work. So sine of 63 is 0.8910. Sine of 75 is 0.9659. And 0.6691 is sine of 42. All right. At this point, it's just a proportion problem. This proportion will help me find out the value of A. This proportion will help me find the value of B. Cross multiply and do what you normally do. So, let's do the A one first. Maybe. There we go. So, if I'm doing A, I'm going to get 0.9659A, of course, for this product. Equals, and then I do 18 times 0.6691. That comes out to 12.0438. So to get A, I simply have to divide that number by 0.9659. That comes out to 12.47. Just like that, we figured out the value of A.
Centimeter?
Yes, centimeters. Thank you, Tucker. Remember they put units on this one. So 12.47 centimeters. If they don't put units, just put the number, but if they do, it's good to put the units there. For B, if I cross multiply, I'm going to get 0.9659B is equal to, and I have to do 18 times 0.8910. That comes out to 16.038. Divide both sides by 0.9659. And that gives me B is equal to 16.60 centimeters. And that's the whole process. So if you get angle, side, angle, that's what they're going to look like every time. You find the third angle, then you have angle, 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 side. So again, whether it's angle, side, angle, or angle, side, once you get all 3 angles, you got 3 angles in the side. One side mixed with its opposite angle makes the middle, and then unknowns over the signs of their opposite angles make the others. And just do some cross multiplying in your proportions to get the final answers. Solving the 3 things we need to know are C, A, and B. We know all 3 things now, so we're